Hello everyone, we are from Sanjani College of Engineering. Here we are representing our learning based project based on force commutation. We have built our prototype model on class C commutation. Hi, I am Roshan Chopra. Now I will explaining you what the commutation means. The commutation is the turning of the process of SCR or thyristor. There are main two types of commutation: force commutation and natural commutation. There are five subtypes of the force commutation: class A, class B, class C, class D, and class E commutation. Our prototype model is based on class C commutation. Now my colleague Maruti Rokde will explain the components used in project.
Hello everyone, myself Maruti Rokde. I will explain about components used in project. We have used two resistors in each branch having resistance of 220 ohm. We have used one LED as a load. It is of 1.5 volt and it is a red in color. We have used a 9 volt battery as source input. We have used two SCRs. Model number is TYN616. One as a main SCR and other as an auxiliary SCR. We have one non-polar capacitor to turn off the SCR. Now I hand over to Rushikesh Rajput. He will explain working.
Hi everyone, myself Rushikesh Rajput. Now we will see how the connection are done with the help of the circuit diagram. Now let's move to the circuit diagram. In this commutation method, the main SCR is connected in series with the load, and an additional or a complementary SCR is connected in parallel with main SCR. Hence, this method is also called as complementary commutation. Initially, both SCR are in off state, so the capacitor voltage is also 0. When a main SCR is triggered by applying gate pulse, current start flowing in two paths. One is the current IL through VDC RL SCR1 VDC. The other is the charging current of the capacitor IC through VDC plus R1 C plus C minus SCR1 and VDC minus. Therefore, the capacitor starts charging up to the value of VDC with the polarity as shown in image. When the SCR2 is triggered by applying gate pulse, it is turned on. As a result, the negative polarity of the capacitor is applied across the anode of main SCR, and the positive polarity is applied to cathode of SCR2, which is auxiliary SCR. This will cause a reverse bias across the main SCR. Hence, it turn off. Now the capacitor charge through the load and the path is VDC plus RL C plus C minus SCR2 and VDC minus. The polarity of the capacitor is now reversed. If the main SCR is triggered once again, the discharge current of the capacitor turn off the auxiliary SCR and the process repeats. Now we will see how the actual circuit works. First, we are connecting the battery for the supply to the circuit. For triggering main SCR, we are giving gate pulse through push button 1. Now we can see our load, which is LED is glowing. Now to turn off the main SCR, we have to give trigger pulse to auxiliary SCR through push button 2. Now we can see there is no current flowing through the LED because of force commutation. Main SCR is turned off by our class C commutation circuit. We have successfully run prototype model of class C commutation. Now my colleague Saurabh Patil will explain advantages and disadvantages of class C commutation.
Hello friends, my name is Saurabh Patil and I will be explaining about advantages and disadvantages of our project. The first advantage is that the current flowing through the capacitor does not flow through the load. The second is that this type of commutation is very reliable, and third is that we can use this type of commutation up to 100 kilohertz. And talking about disadvantages, the first disadvantage is that we use additional SCR to turn off main SCR. The second disadvantage is that because we use additional SCR, the circuit becomes heavy and bulky, and that's from all our end. And we want to thank for Dr. Vijay Kumar sir for guiding us throughout this project. Thank you for giving us this opportunity.